Certificate templates are the blueprint for every certificate your enterprise CA issues. They define what the certificate is used for, how enrollment works, which cryptographic settings apply, how identities are named, and who's allowed to request them. In this module, we'll walk through how each of those pieces fits together. You've already seen the why of PKI, the where it lives in Active Directory, and the who that issues certificates with your enterprise CAA. Now we're focusing on the how. Certificate templates turn that CA into a repeatable, automated issuance engine for users, computers, and services. Think of a certificate template as a blueprint stored in Active Directory. It describes what the certificate is for, what subject information goes in it, which cryptographic settings to use, and who's allowed to enroll. Enterprise KAs read these templates, are configured to issue specific ones, and then honor the rules they contain. That way, every certificate issued to users, computers, or services follows the same policy, making large-scale issuance predictable and manageable. Now, take that blueprint idea one step further. Templates don't just describe certificates. They control how your CA behaves every time it issues one. They determine who can enroll, what identities and subject names look like, which key usages are permitted, and how long certificates remain valid. Because templates drive both manual and auto-enrollment at scale, a single weak setting can ripple across the enterprise, enabling misuse, unexpected certificate behavior, or even full privilege escalation. Template versions control both available features and who can actually use the template. Version 1 is essentially legacy. Basic settings, no auto-enrollment, and mainly there for older CAs and clients. Version 2 and later unlock richer options like auto-enrollment, advanced security controls, and application-specific usage. When you choose a compatibility level, target the oldest CA and client that need this template. If you set it too high, older systems simply can't enroll from that template. Template schema versions are really a contract between clients and the CA. If a client only understands older versions, any newer attributes may be ignored or cause enrollment to fail. That's why we configure template compatibility. It limits which OS versions are expected to consume that template. The enterprise CA then checks both the template configuration and the requester's capabilities. Enrollment, renewal, and management operations succeed only when those two sides line up. A certificate template acts like a policy bundle spread across several key tabs. General defines the certificate's identity and lifetime. Request handling and cryptography decide how keys are created, stored, and approved. Subject name and extensions shape what identity is asserted and how the certificate can be used. Security locks down who can enroll or modify. Issuance requirements add approval workflows, while superseded templates manage upgrades and retirement over time. The General tab sets the basic lifecycle for any certificate issued from this template. Start by choosing a validity period that matches your security and operational needs. Shorter lifetimes are safer but generate more renewals. Then set the renewal period so users or devices have enough time to renew before expiration without creating long overlaps. Give the template a clear, descriptive name that reflects its purpose. Finally, decide whether certificates from this template should be published into Active Directory to help with discovery and troubleshooting. To see how these settings differ, compare two common scenarios: an internal TLS certificate for a web server and a user encryption certificate. For the server, you often allow key export so the certificate can be moved to a load balancer or cluster node, but you rarely archive the key and you typically run enrollment silently. For user encryption, you disable key export, enable key archival for recovery, and usually prompt the user, because losing that key means losing access to encrypted mail. The Cryptography tab determines how strong and modern your certificates really are. First, select a current cryptographic provider whenever possible. Legacy providers are reserved for older applications that can't handle newer APIs. Next, choose the key algorithm and size. For RSA, 2048-bit is a practical minimum. 4096-bit is stronger, but may affect performance and compatibility. Finally, pick a secure hash algorithm such as SHA-256 or SHA-3884 and avoid SHA-1, which is considered broken by current standards. The Subject Name tab controls which identity the certificate actually represents. In many environments, It simply pulls attributes from Active Directory, such as the DNS host name, user principal name, or email address, and maps those into the subject and subject alternative name fields. You can also allow requesters to type in names themselves, but that option must be tightly restricted. Otherwise, they could issue certificates for identities they don't own, creating a serious security risk. Think of key usage as what the key is technically allowed to do: sign data, encrypt, or wrap other keys. Enhanced key usage goes further and defines the scenarios this certificate is trusted for, such as server authentication, client authentication, or code signing. Applications check both. If the EKU doesn't match the task, they must reject the certificate. So when you design templates, enable only the specific usages required for that certificate's job. Template permissions determine who can discover a template, who can request from it, and who can silently receive certificates. Read is typically granted to authenticated users so they can see available templates. Enroll is assigned to the specific users or computers that should request certificates manually. Auto-enroll is usually limited to managed devices or users via group policy. Right and full control stay with administrators only. Misuse of these rights lets attackers alter issuance rules or redirect trust. Issuance requirements let you slow down enrollment when you need more control. You can require CA manager approval or an authorized signer before any certificate is released. That's ideal for high-value certificates like VPN, code signing, or administrative access. Superseded templates handle the lifecycle. You create a new version, mark the old one as superseded, publish it, and clients naturally move to the updated template. Together, these features give you governance, safer rollouts, and smoother migrations. Certificate templates are your policy engine for PKI. You use them to define purpose, identity, cryptography, and lifecycle, then choose compatible versions and lock them down with precise enroll and auto-enroll permissions. In the next module, we'll put this design into practice with manual enrollment, auto-enrollment, and CRL AIA configuration.